Hello everyone, I'm an avatar developed by Yili Lin, a doctoral student in the Health Services Research Program at George Mason University's Department of Health Administration and Policy. In this section, I'll be guiding you through a real-world example using SQL code for corner cases. This block of code sets up the initial dataset for analysis by selecting relevant columns from the lung table. It prepares the data for further calculations and manipulations. This command selects the ID, identifier for each record, and dead, a binary indicator showing whether the individual is deceased, from the lung table. The strata column is created by concatenating various diagnosis codes and other health indicators. The prefix C indicates that this string represents a classification or category. The use of str converts the numeric codes to strings for concatenation. Will be inserted into a new temporary table called data. This field will be used later to group the data based on the presence or absence of specific health conditions. This section sets up a loop to systematically analyze multiple variables one at a time. Initializes a variable to keep track of the current variable index. Sets the starting index to 1. This loop will iterate through a total of 42 variables, allowing for analysis on each health indicator in the dataset. These two blocks calculate the mortality rates for cases and controls, allowing researchers to understand the impact of different health conditions on mortality. Calculate the total number of deceased cases and controls. This formula counts the total number of cases and controls, both deceased and alive. Since dead is binary, 1 for dead, 0 for alive, 1 minus dead returns the opposite state. Modifies the strata string to mark the presence of the current variable by replacing its character with an underscore, creating a new C strata. Similar to C strata, but for the control group. Filters include only those records that have the current variable present, indicating these are case records, and then groups the results by the modified strata, allowing for aggregate calculations on different strata. The same function as it is for the cases group, but it filters the records to include only those without the specified health condition. Groups results to allow aggregate calculations on controls based on the modified strata. This block matches cases and controls based on the modified strata, allowing for direct comparison of mortality rates. Captures the current index variable for reference. Calculates the mortality probability among controls, cases, and rounds it to 2 decimal places. Then select the counts of cases and controls along with the corresponding strata. Performs a full outer join to match cases and controls based on the modified strata. Filters out any strata with fewer than 10 cases or controls, which helps avoid unreliable statistical estimates. This section calculates the intercept for modeling purposes and the overlap between cases and controls. Initializes a variable to hold the total number of cases. Calculates the total number of cases from the cases table. This command prepares to store calculated intercept values in the intercept temporary table. Captures the current index variable number for reference. The formula computes the intercept value using the mortality probabilities. This value is crucial for statistical modeling. Calculates the proportion of cases matched to total cases, indicating the degree of overlap between case and control groups. This counts how many cases were matched in the analysis. This part of the code is responsible for moving to the next variable in the loop, ensuring that all 42 variables are processed. setIndex increments the variable by 1. Each time the loop runs, this line updates the index to point to the next variable in the analysis. This final section searches for the best fitting value of k for use in modeling, applying trial and error. In the context of statistics or data analysis, trial and error refers to the process of estimating parameters, such as the optimal k value, by trying different values, observing the outcomes, and selecting the one that best fits the model or meets a specific criterion. This method helps refine predictive models and improve their accuracy. Create a new table to hold possible k values for testing. Then insert a range of potential k values into the possible k table, covering negative and positive values. This command attempts to find the optimal k value based on calculations done on the previously stored intercept data. This condition checks if the computed value is close to 1, ensuring that the selected k yields a valid statistical model. Randomly select among the fitting k values, which can help in scenarios where multiple values fit the criteria equally well. This SQL script performs a comprehensive analysis of mortality rates based on various health conditions, comparing cases to controls. It systematically builds a dataset, processes it through iterations, and performs calculations to yield insights into the relationships between health indicators and mortality. The final result, which includes the best-fitting k value, is crucial for constructing reliable statistical models that inform healthcare decisions.